And what I'm maintaining is that difference actually occurs because all of those body systems are regulated by our endocannabinoids through those cannabinoid receptors. And it turns out that if you look at some of the basic characteristics, let's say, of insects, let's look at a cockroach, you know. A cockroach a couple 100 million years ago and a cockroach today, you know, they may differ in size and, you know, but they're basically still a cockroach. You know, they never went on to make, you know, the social, intellectual structure that has evolved so rapidly in mammals and specifically in humans. And what I'm suggesting is that even though those proteostomes, those invertebrates, have a very robust ability to survive change, they do so by remaining stagnant. Whereas our whole lineage, we've undergone so many evolutionary changes in a very progressive sense of dealing with complexity. And I believe that that's all caused by how the endocannabinoid system allows us to change in response to change as opposed to remaining the same in response to change. And it's so interesting because, you know, if you look at our immune system or our cardiovascular, of our immune system or our nervous system, those are two systems that have specifically evolved in order to monitor what comes into us. Meaning each of us is a system, a collection of molecules. And we're open systems, which means energy and mass continuously flows through us. And we are, in fact, flow-dependent structures, because if we stop eating and breathing and getting rid of our waste, the system disappears. In other words, we undergo a phase change and die. So we need this constant flow. The flow is driven by our acquisition of energy, meaning eating and getting rid of waste. And it turns out that by being alive and by processing food, and it's inescapable, we make free radicals. And the free radicals are what I call the friction of life. They're a byproduct of electron flow, basically biological electricity, which is how we convert the food into our being, basically. And it's inescapable that we make these free radicals, and free radicals have the characteristic of reacting with anything. They're very reactive. And therefore, they change things. Well, if everything is built on everything communicating properly, and now you start screwing around with both the messengers as well as the, you know, the so-called ears of the cells, the receptors, then you no longer have the biochemical harmony. And the system basically degenerates. It returns closer to equilibrium in thermodynamic terms. Basically, the biological battery discharges, and we get closer to being discharged, meaning back to equilibrium. Health is really a measure of distance from equilibrium, and death is basically a return towards equilibrium, where you no longer can sustain the flow-dependent structure because there's too much disorganization introduced by screwing around with all the chemicals by virtue of the free radicals that we produce, that we have to produce. So we're in a funny kind of conundrum, you know. The free radicals actually have three important roles. On the one hand, they are degradative, you know, because they react and screw up the functionality of our proteins, our DNA, our RNA, our fats, etc. So, but they have other roles as well. For example, we actually use them from our immune system as a means of basically nuking pathogens, be they pathogens in a true sense, meaning microbes or viruses that have infected us, or other forms of danger that we are confronted with, for example, mutated cells that could become cancer cells. So our immune system tries to protect us against all of that, and part of the way it does it is by making these free radicals. Essentially, we make little nuclear weapons, because nuclear weapons work by free radicals in addition to the blast and heat. It's the radiation that is free radicals, produces free radicals by splitting water in the case of high energy photons like radiation. So we have to deal with these events. And then the third thing that we do is that we life, when I say we, I mean all life, has learned how to respond to a changing environment, because that's basically what we're always trying to do. We're always trying to remain in balance with our environment. And change is essentially stress, and stress in turn creates free radicals. But what life has learned to do is to use those changes in their early phases as signals to tell us that we are being biochemically stressed because of change. And this change can occur on a subcellular level, a cellular level. It's like a big fractal, right up the layers of organization to our consciousness, to our social structure. You know, you have a recession, then everybody gets stressed because our economy is stressed, because the flow has been impaired. So, you know, the same paradigms, that once you understand how flow of energy and mass creates everything, and how there is a fundamental creative nature to the universe, you know, you can scope it into conventional terms and call it God, or you could just leave it as science and say, well, there's a fundamental creative nature to the universe. I like the term GOD, meaning generalized open system dynamics. And that way you kind of embrace both the science and the religion, because, you know, the science becomes your religion the more you understand that there is this creative energy flowing through us. We don't have to scope it down into the specifics of a given religion, which are usually limited by the understandings of the time in which those religions originated. We're now in a more modern time where we can kind of be more abstract and use less religious terms, but that address the same issues, really, and that's science. So you know, evolution and how it manifests itself as life, and how we can utilize the knowledge of how that occurred to actually shape our own lives. It's a feedback mechanism, part of this whole communication story that I talk about. So anyway, receptors of the cannabinoid system are fundamentally involved in how we deal with everything. And they regulate everything in our body. And because of the way they have a positive effect on promoting health and life, and in part they do that by reducing the negative consequences of free radicals, here we have something completely unique, this endocannabinoid system regulating essentially aging. It's an anti-aging drug, and therefore it winds up inhibiting all the age-related illnesses, which are things like autoimmune diseases, cognitive dysfunction, and cardiovascular disease, and cancer. So we see that endocannabinoids, as well as supplementation of endocannabinoids by either omega-3 and 6 fatty acids, which go on to make our endocannabinoids, or by direct use of cannabis. All of those things help supplement that system, which is now necessary for modern man. And let me explain that for a second. Because, yeah, see, everything winds up being a balance of opposing forces. You can look at it on a political system, conservatives and liberals. You can look at it economically as boom-bust cycles. But within us, it's the same kind of phenomena happening. It's always a balancing act. And one of the most dramatic balancing acts is whether or not we're producing free radicals or trying to repair the damage that occurred. So typically while we're awake and doing things, we're more metabolically active, we're generating more free radicals, and then we go to sleep at night and our biochemistry tries to restore our balance by dealing with the changes that have occurred during the day. And so sleep is very helpful. And again, if we look at the flow, well, you know, cannabis gives you the munchies because our endocannabinoid system is how we experience hunger. There is nobody on the planet who does not use cannabinoids in the general sense. We could divide cannabinoids into two types, endocannabinoids and phyto or plant cannabinoids. Well, everything in all of our bodies from the time of conception until the time of death is regulated by our cannabinoids. And because we're living longer, and because we live in a cleaner environment today than we did, you know, just let's say 100 years ago, there are profound effects that need to be dealt with. We live longer, which means we accumulate more free radical damage. which means we get those illnesses. Well, those are the illnesses that are killing modern man in a clean society. It's no longer infections that are the leading cause of death. So we have to deal with the fact that we're accumulating too much friction. And that friction is regulated by our endocannabinoid system. If you knock out, for example, the gene that gets you high, which happens to be the main neurotransmitter system in your brain, if you knock that gene out, the mice die prematurely. They don't move a lot because they're too fearful to move. And, clearly the fact that they're dying younger tells you that there's a major impact on being not high. So the question is, how high should we be? And the answer in my mind is a little bit higher than we now normally are, which is why cannabinoids have all these anti-aging properties. So in the past, we needed higher levels of inflammation because we lived dirty and we died young. And now that we've cleaned up our act a little, we have better nutrition and public health and antibiotics, we're living longer, we're experiencing the friction more. In other words, the accumulation of damages that impair the flow because miscommunication occurs. So today, modern man needs to change the thermostat, the balance between cannabinoid activity and essentially free radical production.
Mm-hmm.
So we all need to consume a little bit more cannabis to promote individual health as well as social health. And if we don't do that, if we have what I call the blips, the backward-looking people running the world, they're the people who avoid newness because of their cannabinoid deficiencies. They don't adjust to change, so they avoid it. So their vision of the future is to recreate the past.